Tracking financial transactions effectively becomes significantly easier with programming. That's why in this chapter we dive into lists and dictionaries in Python, because these fundamental objects are absolutely key to write more intricate and efficient code. Now remember, you can find a written version of this course on our website, links below. Let's get going. So let's create a new notebook for this chapter as well. Chapter 3.ipynb. Enter. Great. So let's define our first list. I will call it my list and do equal and put square brackets. So a list is defined in between square brackets. So let me actually then print my list. There we go. And if I run this, what do we get? Empty square brackets. So what did I do here? I actually created an empty list. So let's now fill it up. So a list, you can put pretty much many things into it. So let's fill it up with integers first. So there we go, 1, 2, 3. If I run the cell, I get 1, 2, 3. Perfect. Doesn't have to be numbers. I could go for strings. So let's put in different financial products. So let's say bonds, then I could put stocks, then I could put cryptos, and there we go. And if I run the cell, you see everything displayed. So I didn't mention that, but each element of a list needs to be separated by comma. Okay, we can carry on. A list doesn't have to have all elements of the same type. So we can put strings, we could put a number here, we could put a float, we could put a Boolean as well, and we can even put another list inside. So I could put 1, 2. And if I run it, you see I get everything displayed here. Great. So now, how do we access elements in a list? So let's do a little print here and put my list. Yes. So what you use is square brackets. And I've mentioned that already in the previous chapter. The first element of an object in Python is always 0. Python starts with 0, not 1. So if I want to display bonds here, I have to put 0. There you go. So if I wanted to put the 1, which is the second element, I would have to put a 1 here. Let's see. There you go. 1, etc. Now, so this would be 0, 1, 2, 3, 4. So if we wanted the fourth element, well, we did print 4, and this will show this last list that we put at the end here. Now, what do you think would happen if I put 5 here? Well, we get an error, and you can actually understand what is going on with reading the error here. List index is out of range. Well, simply we went beyond the length of the list, and there's no longer anything at the position 5. So Python returns an error. Great. Let me show you something quite cool in Python is that you can actually start from the end of the list. And this is done using minuses. So if I do -1, well, this will display the last element of the list. So if we did -2, now you probably have guessed we get true. Quite nice. Now, how do you access several elements in the list? Well, actually, you use a column. So let's say we want to start from the first element of the list. So remember, that's 0. And let's say we want to go, well, let's say we put 2. What do you think is going to happen? We actually get only the first 2 elements of that list, bond and 1. That is because what is on the left of the column is included, but what is on the right is not. So 2 is not included, therefore it does 0, 1, and it stops there. If I wanted to have the first 3 elements, I would have to put 3. There we go. Now, let's say I want to have some elements, but I want to jump periodically an element. So what you do is you put another column here and you put the number. So if you put a 2 here, it will mean it will each time jump 1 element. So let me simply say here until the end of the list. So we will see what comes out of that. And you can see we have bonds and 1.3. Does this make sense? Yes, because we start from the beginning because we've put 0. We go until the end because we've put -1, but we're jumping 1 element each time. So I take this one, not this one, take this one, not this one, but the last one is never included. As I said, what is on the right of the column is excluded. Therefore, we don't get this one here. And note that if I remove the -1, then now it goes up until really the end of the list. And in the same way, I didn't need to put the 0 here. So if I did that, I have the same thing. Great. And I can also put a -1 here, of course, and forget about the 0 here if that's what I want to do. Great. But just remember the order. The first number selects the first element is going to display. What is after the right column is the choice of what element up to which it goes. And after the second column, it's the step. So if I put a 1 here, then it's equivalent to putting nothing. There we go. All this might sound a bit a lot, but don't worry, with practice, it will get natural. There's one last thing I should show you is how do I access an element in a list of a list. So we want to get to our last element here. So I will simply leave the -1, and this will indeed give us this list. So now what we're getting is a list. So now I want to access the first element of this list. Well, same principle. I will use a square brackets. And if I put the 0, I'll get the first element of that list, 1. And if I put a 1, well, I will get the second element of that list. Easy. With this new example here, let me show you how you can change elements in a list. It is important to note that a list in Python is what is called a mutable object. It means that after defining it, it can be changed. This is not true for any objects in Python and in general in programming. Anyway, so let's say we want to change the first element of that list in, let's say, crypto. So we use the same rules as we saw just before. So first element will be the one with a 0 in between square brackets. So let's say we said crypto. So then let me put a print assets. Okay, there we go, assets. Okay, so we can just run the cell. And as you can see, first list, we have exactly with this print what we see in here. But now we print again after changing the first element. Remember, 0 is equal to the first element. Then we have, instead of stocks here, we have crypto. Great. Now what happens if we want to add an element to the list? Well, we can use the function that is called append. So if I do now asset.append, then I'll put, you have to open parentheses and then put the element that you want. So here we're keeping the example of crypto. So let me now run this. And what do we see? It appended the element that we call crypto at the end of the list. So with the append method, you add an element at the end of a list. Now, maybe that's not really what you want to do, and you want to insert something somewhere in the list. Well, you use the function called insert. And the way this works is after the parenthesis, you need to put the index where you want to insert that element. So if I did a 1 here and a comma, where do you think this will go? Let's see. Not in the first place, because in the first place, that should have been a 0. I think you got that now. So I did put it right after the first element. So in the second place of the list. Let's see, what would happen if we put a -1? Well, we would put it just before the last element of that list. Great. By the way, I haven't mentioned it, but these .append, .insert, what are they? They are what you call a method. So it is a specific type of function. Function methods classes is what we're going to look into in the next chapter. So now let me show you the final operation you can do on the list. So let me simply copy this, put it here, and it is how to delete an element in a list. So this, you will use a new method which is called remove, and that is if you know which element you want to remove. So if I did remove, let's say, bonds, and I run the cell, you will see the first list, we have everything. But if you look in the following one, the one that is printed after we did the remove, we no longer have the bond element in that list. Great. So this was if you knew what you were removing. But what you can also do is use the del command. And this time you just need to give the index. So if I did asset, let's say 3, what are we going to get? Beg your pardon, I forgot the S, so let me run that again. What did we remove? Well, indeed, the last element, because we went for 3. So 0, 1, 2, 3, we got rid of cache. Perfect. Well, I did mention that was the last, but I want to show you that you can also multiply lists. So let me show you that. So if I did simply assets times 2, what is going to come out of this? Well, you can see that it stacked again all the elements that was in assets after the first asset. So stock, bond, real estate, cash, start again, stock, bond, real estate, cash. And if you did 3, as you will guess, you will stack it another time. Okay, last time we saw loops. So let me show you how you can use loops to scan the elements of a list. So let's do a for and say, as we saw last time, use a range. So for I always forget, in range. And here, let me show you another little function that is very handy with lists, which is called length, which basically returns the length of a list, of the list that you feed in the parentheses. So if I do assets, and I will put a colon to finish the for instruction, and then I will simply do print assets of I. And what are we going to see? Well, indeed, it iterated through each elements of that asset, and at each time imprinted the element in asset placed at the index I. I want to note, though, that this is not such a nice Python way of doing it. And in general, if you're scanning through a list, it is better practice to do the following. For, and I will put, let's say, EL for element, but you could name it whatever you want, in directly the list. So I'll put this now and just do print L. And you will see that this will give us, or let me maybe remove this so we don't confuse what it was what. And as you can see, it gives us the same result. So what happens when you do that is that when L iterates in assets, actually L takes the value of what it is iterating in assets. So at the first stage of the loop, L is equal to stocks. Next step, L becomes equal to bonds, etc., etc. I find that pretty cool. Okay, I think we're well warmed up now. We can move to dictionaries. The main difference of dictionaries with respect to lists is that it is a structure that uses key values pairs, and that's really important. So here I've defined an empty dictionary. So you can note that the way to define a dictionary is by using those curly brackets here. And let's start by implementing what I said, those key value pairs. So let's put one first. So we'll say that key one. So that's the name of the key. And then we need to give it the value. So let's say value one, and we just put it as a string now. So let's see. If we run it, you can see we have key value. Okay, great. So we can add more, of course. Just like list, you can have several elements in it. So let's say key two, value two. Great. Something that I need to show you is that keys are unique in a dictionary. That's a very important property of the dictionary. So if I define key one, value one, and now again, key one, value two, let's see what comes out of it. Well, we get key one equal value two. So you can see keys must be unique. And in case you by mistake put two of them defined by the same key, then what is taken is the last definition of that key. Also, another important point. Values don't have to be strings. This is just an example. I could have put a number here. You could put a list. You could put Booleans. You could put other dictionaries, dictionaries of dictionaries, etc. We'll see that later. But what is important, though, is that the key is a string. So let me just run this so you can see how it comes out of it. Oh, I forgot to rename that to a different name, so that didn't work. But now, okay, key one equal one, key two equal value two. Great. Now let's see how we can access values in a dictionary. So we'll go, I'll actually just copy this again, put it here, and actually even put another print just underneath. And the way that you access keys is very similar to the way you access elements, maybe I should say. Is very similar to the way we did with the list. We use square brackets, but in here, as you might have guessed, what we're putting is the name of the key. So if I put key one, what's going to come out of this? We are printing one. So the value attributed to the key one in our dictionary. Great. If I put key two, well, obviously what I'm going to get is value two. Very good. Now let's see, can we put a value in here? So if I put value two, what's going to happen? We get an error, key error value two. Well, this kind of error basically tells you I can't find the key called value two in my dictionary. And that's correct. The only two keys that we've defined is key one and key two. Value two was an actual value attributed to a key. So very different. So that's the whole point of the game with a dictionary, is that you access the values that you store in it thanks to its keys. Great. So let me put back key one in here. So now let me show you how you can add keys later on after the dictionary being already defined. So let's say you have defined this dictionary earlier in the code, and later on you want to add a key. Well, what you do is it's actually very simple. So now in between brackets, you just put the new key you want to enter. So let me call it hello for a change, and I will define it to be, well, let's say we said it could be lists. So let's do this one and just put a 1 and a 2.2. That's our list. Okay, let's run that cell and see what comes out of it. And as you can see, it added hello at the end of the dictionary. But by the way, notice that really the order of the dictionary doesn't make that much sense at this point because you access it by calling the key. So you don't really care whether the hello was added first or at the end. But note that adding a key value pair like this can only be done if the dictionary has already been defined earlier. So let's say, for example, now this should be another dictionary. So let me call it like this. And actually, you already guess there's going to be an error because VS Code underlined this. But as you can see, name my dict2 is not defined. Okay. But one way of doing that, you can totally define it as an empty dictionary early in the code, and later on you'll fill it up, and that would work, no problem. I should actually also do print my dict2, so we see both of them. Great, as you can see, it works fine. Okay, so let's go back to what we were doing at the beginning, and that's what we were going for. Very good. So we've added keys. Now, how do we delete one? Well, we will be using, again, that function del. So we will write del my dict, and we need to enter what key we want to delete. So let's say we are going to delete key 2. There we go. And let me now also print after that. And as you can see, first print, we have all our key values. And because we deleted the key 2, what actually was deleted is indeed the whole key value pair that was attributed to key 2. Great. I think we're ready now to have a look at how to scan through a dictionary using a loop. So let me simply define this dictionary that I prepared, which just regroups a few names of financial products, and I kind of give as a value the definition of that financial product. Okay, so we will do a for loop and go for key. This here, I'm just naming a variable that is going to take on the name of the key, but it's really a name, so it could be whatever. It could be whatever, and then that would be fine. But let's call it key so it's quite intelligible. So for key in, and here we simply write the name of the dictionary we want to scan, asset info. Always finish the for instruction with a column, put enter, we have our indentation. Great. So let's do a print. So now, as I said, this key variable here is taking on at each step the name of the key. So we will put key, then say asset info of what? Well, we want the value that corresponds to that key. So I'll put key here. And I think that's enough. Let's run the code. And there we go. Actually, we can make it a bit more intelligible and put maybe just definition here and just put a column here in the sentence, finish by a little comma, and let's run the code again. And as you can see, stocks, definition, investment in company shares, etc. So we have scanned through the dictionary. And here in this example, we're just printing what's inside, but you could start doing operations on the values of the keys or add new keys, etc. I just want to point out that here we're actually using a shortcut, and what we could have done, but is not necessary, is this. We're saying key should take on the values of the keys of asset info. So let me run this so you see that the exact same thing comes out of it. While I'm talking about this, let me show you actually what you see if you do print asset info. And actually what I want to show you is the second one. If we do print asset info dot keys. So you can see we have our dictionary as usual. But the second print, we have an object that is called dict keys. And we see inside something in between square brackets, which regroups all the keys that we had in the dictionaries. And actually, if we wanted to convert that to a list, we could totally do list of that asset info.keys. So let me run that. And now you see, you have a list of the keys that are contained in our asset info. And here, by the way, you can see that the order is conserved. So the order of the keys displayed in the list here is indeed the order in which we have defined the keys in the dictionary. So you might wonder, we've made a list, we've accessed the keys of the dictionary, printed it. Can we do that with the values? Well, if I'm saying it, you might guess that of course we can. But so this, you use the method called values. So if I do that, we have a list of the values. Great. And by the way, if I remove the conversion, you will see that the name of the object that comes out, the type is what is called a dict values. Not that it is super important to know that, but now you know that you can do these conversions in case you need to, etc. Anyway, the reason why I'm saying that is that because in this example, it kind of made sense to access through the key because we wanted to get the definition of our financial product given its name. But you will have some uses where it's better to access the dictionary and scan through it via the values. So let's just simulate this here and say that what we're doing here is actually, let me just call it value now, just give it a different name and actually put values here. And then I put my parenthesis. So we don't have the key anymore, but I'll just put value because we can't access the key anymore at this point because we're scanning through the value. But let me just show you what comes out of this. This is indeed printing all the values of all the key values pairs stored in our dictionary. Okay, so far we've used very simple dictionaries, but what I want to bring your attention to is that thanks to this kind of structure, we can really start storing intricate, involved information and in a very intelligible way. For example, here I'm pasting a more complicated dictionary, but it is actually very neat in the way things are organized. So you can see I've called it my portfolio, and basically I have two types of stocks stored in there. And for each stock, I store some important information. For example, you have a key called information, where you have a common name, whether the market is open, the currency, etc. So you can see here what happened is that I defined a dictionary inside the dictionary. And here, however, outside of that dictionary, but within that dictionary here, I store, for example, the quantity I have of this stock, the current price, the last 5 days price, etc. And I have another entry to the very first dictionary, which is now Google Stocks with the same kind of information. Great. So let's have a look at how we can access each of this stuff. It could seem a bit tricky, but it is not. It's just important to know what kind of object you are accessing each time. So let's do a print my portfolio. Okay, so what are we going to access? So let's go in Apple. Okay, we'll go for Apple. So if I want to access something that is in information, well, I have to go into information. Well, actually, let me simply do this. What will come out of this? Well, what is inside Apple, which is a dictionary which contains a key information. Inside of that, another dictionary, but we have also the key quantity, inside the number, current price, etc. So now let's say we want to actually access the currency in which this Apple stock is traded. So we'll have to now put information. And what did we say we wanted to access? The currency. So I have to do, again, currency. So I access the value that is stored in the currency key of the dictionary information, which itself is in the dictionary APPL, which itself is in the dictionary my portfolio. Anyway, let's simply run this and see what comes out of it. Dollar. Great. That's what we wanted. Now, say I want to know the quantity that I have. Well, this I have to remove, and I'm back at this level here. Note that for display, indentations, very important to make things very clear. Anyway, so I said we wanted to do quantity. You can see that this is at the same level of the information dictionary. So we actually have to come back at this place here and put quantity. Great. Okay. A bit more difficult, maybe. We want to come and access the price, one of the prices in the last 5 days. Okay. So I'll simply copy this. So you would understand that I can't change this one because all these keys are at the same level. So I'll do that. So if I do that, what we're going to print is indeed the list that's in there. what is coming out of this, we can see that it is a list. So now if I want to access an element of this list, we need to follow the procedure we learned about list. So if I want to get the first element of that list, we will simply put a 0 here. And great. And the very cool thing here is, say I want the same thing now, but I want that of my Google stock. Well, I simply change this because, oh, that's 1 O too many. Okay, because we have kept the exact same structure between what's in Google and in Apple. That doesn't have to be the case, of course, but in this example, it is. So let's simply run it. And you can see now I indeed have that number here. Great. Now let's do an example where we're actually doing something wrong. So let's say that we forgot that last price, 5 days price is actually at the same level as the information key. So let's say I put it here and I close the bracket. Okay. So if I did that, what's going to come out of it? A key error again. It's saying there's something wrong with the key last 5 days in price. Basically, same error as before. It's telling us it doesn't find last 5 days price. And why is that? Well, because this key here does not belong to the information dictionary. It is outside of that. And as we saw, this would be the right way of doing it.
Nice. Now I want to talk about a few potentially confusing aspects about lists and dictionaries. You are likely to make some mistakes with this, as we all do. So let's take a careful look.
We're going to create a first list. So let's call it list 1. And we'll simply say that this is, well, let's say 0, 1, 2. Great. Okay, let me then print it. And I'll go list 1. There we go. Okay, now I'm going to create another list called list 2. And I'm simply going to say that this list 2 for now is equal to list 1. Okay. And like what I'm going to do next is print that list 2. There we go. Let's run it and let's see what comes out of it. Makes total sense. List 2 is equal to list 1. So when I print list 1, I have this. And when I print list 2, I also have this. Perfect. Now let's say that we want to change one of the elements of list 2. So let's say, for example, the first one, and we're going to say that this one is equal to 55. Okay, what am I going to do? Well, let me just print list 2 again. What do we see? Oh, I made a mistake here. Beg your pardon. There we go. Okay, so far so good. We have the 55 that replaced the 0. Very good. Okay, now. Let me print list 1. And what do you think is going to come out of this? If we follow the Python logic that we've been going through in this course so far, well, in principle, list 1 should be exactly what it has been defined, because nowhere after have we changed any elements of list. The one that we changed is the first element of list 2, and we're printing now list 1. Okay, so let's run and let's see what comes out of it. And not at all. We see that actually the first element of list 1 was changed exactly like it was done for list 2. However, we have never coded it. We only did it for list 2. So what's going on here? Well, this is a deeper aspect of Python coding, which is referred to as referencing. So what we're actually doing here when we set this equal between list 2 and list 1 is what we're actually saying is list 2 needs to point to the same reference than list 1. So afterwards, when we're saying change the 0th element of list 2 by 55, we are changing the reference. And therefore, since list 1 points to that same reference, well, when we print list 1, it gives us the 55, just like it did for the list 2. So as you understand, for int, floats, all these more standard variables, this doesn't happen. You get to this referencing aspects when you move to lists and also dictionaries. So this could be handy, but could also be a problem. So if you didn't want this to happen, what you can do is use a method of lists, which is called copy. So what you're saying now is actually what it will do is create a new reference for list 2, which will be the copy of the values that are in list 1. So let's run this. And as you can see, we no longer have this change. I mentioned that this happened as well for dictionaries. So let's quickly look into an example. Let me simply paste it here. So what I do here is that I have a first dictionary, which I say has only a key A, which has the value 1. Great. We'll print how it looks like. Then I say that a second dictionary is going to be equal to our first dictionary. And what I'm doing is that on the second dictionary, I'm defining a new key B, which is equal to the value 3. And as you are guessing now what's going to happen, what I wanted to show you obviously is dict1. That dict1 has this key added when we never added it to dict1, we did it only to dict2. But because of that referencing, we changed the reference of both dict2 and dict1 by changing dict2 and adding b to dict2. Therefore, when we're printing how dict1 looks like, we get that it has a b as well. So same thing, the remedy is exactly the same method which exists for dictionary as well, is this copy method. So if I do that now, we see that we have in dict1 only the keys that we defined at the beginning. And maybe I never printed dict2, but maybe I should print dict2 so you see that dict2, on the other hand, has both keys as it should. A little caveat I need to mention now. If you're using dictionaries or lists of dictionaries or dictionaries of lists of dictionaries, etc., big complicated things where you have a sort of structure of dictionaries in dictionaries with lists, etc., using this simple copy here might not work. And in that case, you need to use what is called the method deep copy. So I'm not going to get into details. I'm just pointing it out that sometimes the copy for more complicated structures won't be enough, and you'll need to use deep copy. But I'm leaving this up to you to look into if you ever find yourself in a situation where the copy is not enough.
Okay, as usual, I'm not going to let you go just like that. Time to finish with the little practical exercise.
As usual, guys, you will find a written version of this course on our website. Anyway, I'd rather tell you right now, this exercise is going to feel a bit tricky. This is to force you to really dig by yourself to try to solve it, so really don't hesitate to go search the web for help. So the point of this exercise is basically to deal with this list of dictionaries, and in each dictionaries, what do we have? Transactions. So you can see different crypto transactions. For example, the first one is on Bitcoin, where it was a buy, the quantity is written here, the price at which it was bought is written here, and that was a date. And you can see the next one, for example, is a sell on BTC, etc. So you have a few on BTC, and then you get to some on Ethereum. So the first question is kind of a preparation, if you want. We want you, by using a for loop, to scan through this transaction list and single out in a new dictionary the cryptocurrencies that appear in all the transactions. So you would start with an empty portfolio, with portfolio equal to an empty dictionary. And with your loop, you fill it up and the result should look like this. The reason why we're doing that, you might understand, is that maybe because in the future, a new cryptocurrency would come into your transactions. So you want your code to be automated. And therefore, with this loop, it will just classify everything nicely. Now, second question, quite easy. You do with a loop again, you want to add a quantity key in each cryptocurrency dictionaries, and that quantity key should compute what is left of the amount of that cryptocurrency at the end of all those transactions. So indeed, those type of questions will ask you to use some if-else conditions, etc. Then third question, now you need to add a key in each of the cryptocurrency dictionaries where you compute the P&L given a price of the currency today. And fourth question, you also add a key to those dictionaries where you store the result of the computation of the average purchase price for each of the cryptos. And we finish with a bonus question. This one is quite tricky. Here, for each crypto, we ask you to display the quantity purchased after the date of this one here. So that means you will need to do some tests, but also you will have to use the library called datetime. We will be looking into how to handle dates in a few chapters quite in depth. But here's a little introduction if you want to try to push yourself. They would be beneficial for you if you already tried to solve this question now. Anyway, as usual, you will find a link on our website to a suggestion of correction of this exercise. But again, the more you do by yourself, the better it is for you and your learning process. Also, don't write all that by yourself. Just come on the website and come and copy this transaction list.
That's all for today, folks. You take care. Don't forget a little like and a subscription, and please share this course with anybody who might benefit from it. See you in the next chapter.